Not only does it take energy to heat stuff up, but it also takes energy to change phases of something. That's what this screencast is about, the energy of phase changes. We're going to apply this specifically to the energy of phase changes for water. This is screencast 12.8. We'll ask ourselves, do phase changes require energy or do they liberate energy? Well, it depends on what you're talking about. And we'll describe the 5 steps that are required to convert ice into steam. And we'll take a look at it and determine which one is the most energy intensive. Let's go ahead and start. Here are the standard enthalpies of vaporization and fusion. For water, to boil it, that means to turn it from a liquid into a gas, is going to take 2,260 joules for every gram if it's at constant pressure. That's why they use the term enthalpy rather than heat. Similarly, if we're going to melt it, that is, to take ice and turn it into liquid water, it requires 334 joules per gram. Note how much more energy intensive it is to boil water than to melt it. So that would be right there, the enthalpy of vaporization, turning water from a liquid to a gas. And here it is to melt it. They don't use the term melting, they use the confusing term enthalpy of fusion. 2,260 grams, 334 joules per gram. It must be equal and opposite to do the opposite thing. So think about that. To condense water, to condense it from steam to a liquid, from a vapor to a liquid, will liberate 2,260 joules per gram. It actually releases heat to the surroundings. Simply solidifying it, that is, to freeze it, liberates 334 joules per gram. These are the enthalpies for vaporization, fusion, condensation, and solidification of water.